Okay, back to the board. Now, I have done quite a bit off of camera to this because I'm sure y'all noticed that I've had this section of the board blurred out the whole time, and it has been a total pain going back through and editing that video to blur this out. The customer's name is on the board right here, and I don't really like putting that out there if I don't have to, so I didn't really notice it before when I was working on it. No, I did, but I just didn't think about it. So I put a piece of tape over it now. But yeah, what have I done? First off, I realized something, and I don't know why Exidy does this, but they did this in the late 70s and maybe even the early 80s, because I remember I did a TARG, T-A-R-G, board repair about I don't know, half a year ago or so. Exidy, 1979, something like that. And I remember I had to adjust the horizontal frequency on the G08 to get that to come in, because the horizontal frequency was 17 kilohertz from the Exidy board. Well, yep, you can see here, it's up here. But the same thing with this. The horizontal frequency runs at 17 kilohertz for some, I don't know why they did that. I really don't. But I believe that is just standard Exidy for this time period. And I could not get that to come in on this monitor. So I had to actually put a 12.096 crystal in this thing so that I could get this on my screen. I had to slow the frequency down, the main frequency down, so that I could get this to sync. Yeah, really strange. I don't know. But anyway, I got the power supply done yesterday. And I have the power supply running the board right now. And as we remember, this thing pulls 5 amps solid. So this thing is doing very well, running it. No problem. What have I done? Okay. Remember the hackery up here, up in this section. I fixed all of that. All of that hackery I fixed. You know, did proper trace repairs on this thing. Okay, that was one thing. Another thing is, while I was confused over the horizontal syncing and why it was running at 17 kilohertz, that was throwing me for a total loop until I remembered back to the TARG repair. And I didn't mention that in the TARG repair, but I just remember it from when I was doing it. I went through and I changed a bunch of chips. I changed the counters, the horizontal and vertical counters, some of the 112s, the flip-flops that divide down the clock, 174 that's involved in timing. I changed some of the timing stuff, and I was getting the exact same thing. And that's always a bad sign when you start replacing chips that test good to try to find a problem that doesn't exist. That's just the way this thing is engineered. I don't know why they did that, but that is what Exidy did. So it is what it is. I put a new Zener diode in this thing just because the one that was in it wasn't even through hole. It was kind of soldered just onto the board. And I didn't like that, so I put a new 15 volt Zener diode in. And yeah, we should have 15 volts right off of the emitter of this transistor. And I had to redo this transistor because I don't know what's going on. It was not making contact through the through holes. Like someone had removed that at some point and tore the through holes out of the board. So I had to redo that. Because initially I had no voltage. I had no 15 volts powering the amps. And that comes off of the emitter of that guy. So I just had to redo that. And I would like to actually, this should have 15 volts on the cathode. And there it is. Oops. There we go. Yeah, that Zener diode right there is regulating that 15 volts from the emitters, or the base has, that was base collector emitter, I believe. So the emitter has 15 volts on it, and the off of it, and the base and the emitter both have 15 volts going off of this thing. Yeah. So the sound section is actually working, but I am still missing that one cap. I have not got that cap yet in the mail. It's a 47 nanofarad that goes there. I don't have that yet. But I can coin this thing up. I don't have steering capability yet. I'm going to wire in steering. But if I coin this thing up, 1, 2, 3, 4, 5, 6, 7. Both cars. There it is. Both the cars' sound is working. I'll start again. You got to hit start before it starts counting and stuff. That's 6. 1, 2, 3, 4, 5. Okay. Gas, gas through left car, right car. 16 and 17 maybe. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15. Okay, now I am curious as to why this guy is always moving. Like like I don't have gas on right now. I don't think that guy should be moving at all. It's funny how they get big up here and small down here. That's just got to be with the weird sync. Ooh, that didn't sound good. But I'm missing a cap, remember. I don't know if that is part of that circuit. It's good that the sound was actually there, though. Yeah, I gotta check into this. I don't think the white car is supposed to be moving without the gas pressed at all. How this one acts, I have to actually short the gas input to ground for him to move. So yeah, I don't know. I'm gonna have to look into that. This one might. That's the left car. Yeah, I don't know. It's something to look into. Left car circuit. But yeah, so I gotta wait for this cap here to come in. That might have something to do with that screech sound. I don't know. All right. Anyway, I'm gonna look at the schematic on in the left car and find out why that one is moving without the gas being pressed. Okay, I'm probing around here. This is left car, player one, left car, and here are the two gas inputs. And this is the one I want to look at. It comes into 4L, pin 5 out to 6. That is this guy. 4, or pin 5, is the input from the board. And this is the output. Of course, it's an inverter, so it's low. So when you hit the gas, this goes low, this goes high. Okay, so that's pin 6 of 4L. That's this guy right here. And then that goes to pin 9 of 4L, which basically inverts for the JK inputs. So let's check pin 9 of 4L. Pin 9 of 4L, which is this one, 7, 8, 9, and it is low, and then the output is high, of course. Oops, sorry. Pin 9 and pin 8 is high, so that works. That's good. And pin 6 is directly connected to pin 11 of 5L. 5L is this guy right here. So pin 11. So pin 6, which is a low input, goes to pin 11. Here's 8, 9, 10, and 11. 11's floating. So that is a bad trace. We have a bad trace from pin 6 to pin 11. And I bet you after we fix that trace, then that car will act normally as it should and not move on its own. So let's go ahead and fix that trace. Okay, so now I just turned the board over and just kind of had to solder it a little better than it was. Remember, this was really hacked up. So now it's low. Now it's connected. And I want to take a minute to explain. I'd been working on this board, right, with the switching power supply hooked up to it, and I had to actually hook this to ground. This goes through my big analyzer to earth ground so that this thing wouldn't be completely waved out. I mean, it was terrible wavy, but as soon as I would ground it to earth, it would settle down like this. With a linear power supply, you don't have to do that. It's so much less noisy, and things just are so much better with the proper linear power supply. That's why it's always better to stick with the linear supply if you can. If it's rebuildable, rebuild it and keep that linear supply in there, because your game system will be a lot happier with a linear power supply. There's my PSA for the day. But yeah, so now we've gone and fixed that. So let me see if the white car no longer strays on its own. I'm going to put 2 coins in. 1, 2, 3, 4, 5, 6, 7. Start. There we go. Now we're starting, we're counting, and he's not going on its own. So that's a success. Okay. Pin 11 is go for the white car. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. Get him! Get him! All right, I'm going to try to hook up my steering so I can use a trackball. And it's going to be a situation where I use the trackball to steer both the cars. Kind of like I did with Sprint 2. And yeah, try to run some of these gremlins down. And that's better. I had to mess with both the vertical linearity pot and the vertical size pot so that it wasn't stretched out bigger up here and smaller down here. Yeah. Now it's uniform across the whole screen, same size. Yeah. All right, yeah, I'm going to go ahead and wire up my trackball and chase these guys down. Chase them down. Okay, I'm just looking at the schematic for the Scream sound, and it's two 566s. And then it has this 6040, and it says it can be replaced with a MC3340. But my board here has this stuff in the board. So I don't know what is going on there. But what I did notice is I forgot a capacitor right there between pin 7 and ground, and that is on the top chip. I have these labeled top chip, bottom chip. It's a 0.1, so I'll put a 0.1 in there and maybe that'll fix our Scream sound. And if it doesn't, then I don't know, we'll have to figure out what's going on here. I got two 566 function generators in there, and I hope they're both good. But that's an effect that you have to have that effect. That Scream effect is what makes the game kind of creepy, to be honest. So we'll figure that out. I forget actually what I was even doing, to be honest with you, what I was going to do before. But since I noticed that cap's missing, I'll put that in there. That's easy. That's a 0.1. And then we'll revisit. Oh yeah, I need to take it apart anyway because I need to wire up my trackball. And I got to figure out the gearing. Am I just going to short the gearing, so that I can move and yeah, that's probably what I'll do. So the main thing is I want to be able to steer the car. So, all right. Alrighty, a couple things to do. I'm going to get to it. Okay, I have wired in the trackball, and I made another little change to the power supply. I put, as you can see, that is a 4.7K 3-watt resistor just across the terminals, and the only purpose that is to drain the charge off after power's turned off. That's just kind of a safety thing. Just discharging the cap after the power is turned off. That's all that does. But we're running. I've been playing it a little bit. Both the steering works. I'm going to turn player 2 down. I'm going to put gas on player 1. Okay, and I'll go ahead and start a one-player game. 1, 2, 3, 4, 5, 6, 7. Get over here. Gotcha. Ah. And remember, the sound isn't going to be right because we're still missing that capacitor in the sound section right there. I did put that cap in that was missing, and it changed that sound a little bit. But we really got to wait till we get that cap. But after this times out, I'll go ahead and start a 2-player game, and you'll see the problem with 2-player is the engine does not rev up. So I'll go ahead and start. I'll put gas on the 2-player guy right now. And we'll just have to wait for this to time out. I'll be right back. Okay, it timed out, so we'll start 2-player this time. I'm going to turn player 1 volume all the way down and turn up player 2 a little bit. And we'll start a 2-player game this time. 1, 2, 3, 4, 5, 6, 7. 7. Start. Yeah, see? The engine doesn't change. Steering works. This is hilarious. Yeah. So we have the engine issue. It just won't rev up, so we'll have to look into that. So let me get the schematic out and look over the engine sound for player 2, the right car. Okay, this is the audio motor speed. And you have these 3 signals, the motor speed signals that come from page H. 3 bits basically, and they become an analog signal. And they turn this guy on, this 3904. This 3904 is open. It's not reading right. And if that's not open, this thing's just going to idle. If that's not ramping up, turning on. So, yeah. Turning on to certain degrees based on the input on the base. So I'm going to go ahead and pull that transistor. It is this one right here. This is a complementary pair. There's a 3904, 3906. The 3906 tests okay. This one tests open. Yeah, and I'll show you that. Let me. This is this is the other car right here, the same circuit on the other car. 3904, 3906. Same circuit over here. So this side is working. Remember, this car, the motor ramps up. So we'll go through the meter with the meter, and I'll test both of those, and you can see the difference. Okay, and we're going to be doing these two transistors right here and here against these two over here. Remember, this is the section that works, and this is the engine section that does not ramp up. So just, you can keep an eye. You know what, I'm just going to zoom in on here, and I'll tell you what I'm probing so that you can see the difference. First, we'll do the good one, right? Excuse the sniffles. 'Tis the season. Okay. First, I will do the good, and it's the 39. We'll do the 3906 first, which is the PNP transistor. So we should have a good-looking diode drop here and here. Okay, and now we'll do the switch it up. Can you still see that? I had to move the light. Yeah. Now we'll do the 3904. So we'll do that right here. Looking good. And over here. Okay, that's the side that works. Now we'll do the side that don't work. First, we'll look at the PNP one, the 3906. Okay. Okay. Good. And good. Now we'll do the 3904. And that's one diode drop. And here's the other. So something is wrong with that circuit. That is not good. So I'm going to remove that 3904 and we'll test it out of circuit. Okay, I removed that transistor from the board. I'll show you where it went. This little guy right here. 3904. We'll go through and test that thing. Remember, it looked like it was open. So let's, yeah, I got it right here. Kind of zoom in to where we can see the meter, hopefully. How's that? There we go. Okay. And let's do a test on this one. It is a NPN transistor. So we'll go from red lead on the base and then to both the emitter and collector. And here is, the leg dam broke off. Almost. Okay. Here's, yeah. There's one of them open. Yeah, that is base to emitter. Junction is open. And then the base to collector junction is also open. Which I can't really get on right now because some of this transistor leg broke off. There, now I'm on it, and it's open. This thing's open, completely open, both ways. Completely open. So that's junk. Into the trash it goes. Okay. So we will replace that guy, the NPN one. Remember this one, the PNP test seemed to test okay. And I don't like what's going on up here. I've done some searching on the internet, Google, and none of the death race boards that I have found online have this jumbled mess. It's either got, like it says in the schematic, the 8-pin chip or that little spider-looking attenuator. It's an attenuator is what it is. And I do have those chips in stock. I have a few of them. They're not cheap, but they're extremely kind of rare. So I'm going to go ahead and remove all of this nonsense and put whichever one I have more of. You can use either or, the little spider guy or the 8-pin chip. So, yep. I'm going to do that. I think once we do that and we put the proper circuit in here, the scream sound will be correct, I think. So, let's do that. Okay. Put an attenuator in the board for the screech sound. Replaced these two transistors right here. I replaced both of them as a pair. The one was open, the other one tested good. So let's go ahead and play a game, and we'll start off with player 1 car. Sounds perfect. Come on. Get back here. Ah. All right, that's it for that, but we have an issue. Let's switch over to the right car, car number 2. You'll see the sound on that is completely wrong. The sound on the engine is not right. See that? Enough of that. Yeah. So there's still something wrong in the analog circuitry with sound number 2, car number 2's engine sound. So we'll have to look at that. But we got the screech. The scream is fixed. That was that. I don't know what they were doing with that junk up there, but so that takes care of that. Now we just got to figure out why this isn't sounding right. There's some component that is just not good. I think it's an analog problem. So we'll find out. All right, and for this cap, instead of waiting, and all it did was cleaned up the engine sound on number one car. I had a 39 nanofarad cap just kind of loosely in there when I was doing the testing, but it was making connection enough to where it was cleaning it up. Well, for the permanent solution, I went ahead and put two 22 nanofarad caps in parallel with each other. So it's 44 nanofarads, and I soldered that into the board. So that takes care of that. So now I'm going to start poking around over here and see if I can find anything bad in that schematic, in the schematic part over here. Okay, I may have figured out the problem. I was just checking the resistance on all of these guys, and this one on the end is open. And if you look really close to this guy right here, let me zoom in. You see it broke? It's cracked right there. It's cracked. And it's open. There's no resistance. It's supposed to be 3.3K. Yeah. Interesting. So, yeah, I was just going down and checking all the resistance on all these guys, and they're all looking good. And I got to this one, and it was right by this. So, obviously, this transistor that was in the board right here got pushed back and broke that resistor. So, yeah. I'll go ahead and replace it, and that should do it. Okay, we're back in business. Got a new resistor right behind that transistor there. 3.3K. And let's try car number 2, the right car. Let's try that one first. So let's go ahead and coin up. I had to turn the volume up. It's working. Wow, that's loud. Score works right. Game counter works right. You know what? Let me go ahead and set the tripod up, and I'll do one game with player 1, and then I'll do another game with player 2. Okay, here we go. I'm going to do the first game with player 1, and then the next game I'll do with player 2. And keep in mind, this is running on the power supply that I fixed. Okay, let's do this. This one I'm only going to do one player, so the white car. I know I don't have reverse hooked up, jerk. That's going to be hard to beat. But we're going to give it a shot. I'm switching over to car number 2. And here we go. Ah. Go! Oh, I got 11. So what, I get 12 the first time? 12, 13, something like that. Let me go turn the lights on. Pretty awesome. Fun. Awesome fun. Yeah, weirdness with the crystal. I know it was the screen kind of jump around a little bit. It's not even a perfect sync right now. I have a 12096 and what is the frequency? Let's check it. What is my horizontal frequency right now with that 12096? I know it's 17.2 kilohertz with the standard 14.391 crystal. And it's like pin number, it's board number T. And I finally did start to understand how to read this schematic. It's really not that bad. They just have every signal named with a number. Let me go ahead and yeah. And let's go auto measure. And where exactly are we going with this? Sync signal is right here. CSC, 1T CSC, 1T. I think they named it wrong right here. They put SCS. I think that's a typo. So I think it's actually pin 12 of the 174. So what I'm going to do is 174 is right here. And let's just go on pin 12. Darn it. Come on. Okay. And zoom, zoom. Yeah, see, it's 14.5 kilohertz. And I can get this monitor in on it pretty good. You know, I would say if you put about a 13.5 megahertz crystal in this, which you can get from Mauser, what I would do is I would experiment around. I'd put in a 13.55. I think you can get a 13.22, 13.7 something. I would experiment with crystals until I got as close to 15.7 kilohertz as I could. And that's what I would do. Because standard stock right from the factory, this thing runs at 17.2 kilohertz, and it just doesn't make any sense to me. You know, that 12096 is a little low. Like I said, if you had a mid 13, anywhere in the 13s, I would try a bunch. I'd try like four different 13 megahertz crystals until I got as close to 15.7 that I could. Yeah. The 1209 comes out to 14.5. Little low, but it's better. It's easier for this monitor to sync to than 17.2. Anyway, I'm going to send it back I'm going to put the 14.391 back in it. So that's going to do it. I'm going to wrap this one up. Let's turn this off. Okay, yeah. Just kind of interesting stuff. So we have a complete system electronics repair on this guy. Power supply and the board. So I'm going to let this sit here and run for about 3 hours with the power supply powering it. That's going to do it, guys. Thanks for watching again. And we will see you all on the next Classic Arcade Repair. Bye for now.